Hello students, welcome to ALPHORES e-learning channel. This is K. Nageshwar Rao, your physics faculty. Today we are about to deal with the session number 98. In the previous session we have discussed potentiometer principle and also we have discussed theory of potentiometer. And before that we have discussed meter bridge connected with a few problems, and before that we have discussed Wheatstone bridge principle. Okay, this is what we have been doing in the last few 4 or 5 sessions. And today we'll discuss about problems connected with potentiometer, problems connected with various other topics. Okay, so let us proceed. So before I proceed with the problems, let us recollect what was completed in the last session, in the previous session. See, when we have discussed theory of potentiometer, few important conclusions were drawn. One of the important conclusion is potential gradient. Potential gradient, it is represented with x, and it is written as x equal to v by L, and which is equated to I into R by L. This is one kind of equation where this R is resistance of the potentiometer wire, L is length of the potentiometer wire, and this I is current flowing through the wire, and this V is potential drop per unit length, and this is what we call it as potential gradient. Potential gradient, isn't it? Gradient. And this equation can also be modified like this. X is equal to I. This I can be written as EMF E divided by total resistance offered by the primary circuit. I told you yesterday in potentiometer, primary circuit, and if a potentiometer is connected to some other circuit, then that the other circuit is called as secondary circuit. Whatever potentiometer main circuit is there, that is called as primary circuit. So in the primary circuit, whatever resistance is there, that resistance is internal resistance of the cell plus series resistance plus resistance of the potentiometer wire multiplied with R by L. So this is what I is. Current in the potentiometer wire. I is equal to E by R plus RS plus R, where this R is internal resistance of the cell and RS is series resistance and capital R is resistance of potentiometer wire. So whatever problems we'll be dealing with from now onwards, all those problems are connected with this one only, with these details only. If you want, you can replace this R by L with the resistivity also, resistivity or specific resistance, both are same. R by L is what in terms of resistivity? Rho by A, isn't it? So that's how you can replace. So therefore, this equation can also be written as X is equal to what? X is potential gradient is equal to I into rho by A, or I into rho by pi R square, where R is the radius of the potentiometer wire. So these are the few details that we have discussed in the previous session. Okay, so now let us try to solve problems. Now let us try to solve this problem. A potentiometer wire of 10 meter length and 20 ohm resistance is connected in series with a resistance 80 ohm and a battery of EMF 4 volts. Potential gradient on the wire will be, okay, so it is connected to a battery of 4 volts, and what we have to find out? We have to find out potential gradient on the wire. So try to identify what data is given here. So potentiometer wire length is given, capital L is equal to how much? 10 meters, isn't it? And 20 ohm resistance is connected in series with a resistance 80 ohm. Okay, so potentiometer wire of 10 meters length and 20 ohm resistance. So potentiometer wire resistance is how much? 20 ohm. Okay. And it is connected in series with a resistance 80 ohm. So here series resistance R is 80 ohm and battery's EMF is given as 4 volts. Okay, these are the details given. What he is asking for? He is asking for potential gradient. If you wanted to find out potential gradient, what you can use? You can make use of this one, right? You can make use of this equation here. Here X is potential gradient. And look at this equation. Here small r is also present. Small r is also present. But here in the given question, regarding internal resistance, there is no any information. What does it mean? How to handle this question now? Remember students, if any information regarding internal resistance is not given in the question, it means whatever cell he has taken in the question, that cell is ideal cell, and for an ideal cell internal resistance is 0. So R is 0, small r value is equal to 0. So that's how you can start with. So pick up this equation. So how this potential gradient can be written? X is equal to E by R plus Rs plus R into R by L. So now all the data is available here. So just substitute here. So 4 by small r is 0, Rs is how much? 80 plus capital R is 20. Capital R is potentiometer wire resistance into potentiometer wire resistance, which is 20 divided by length of the potentiometer wire 10 meters. Okay. See here, children, unlike in the case of meter bridge, here there is no any restriction on the length of the potentiometer wire. You can take any length of the potentiometer wire. It depends on what experiment you are performing. It depends on where you will be getting balancing length. I'll tell, we haven't gone into the details much. We'll come to know what balancing length and why do we need more than 1 meter length of the string in potentiometer. Okay. So here the wire can be, in case of potentiometer, it can be more than 1 meter. Whereas in case of meter bridge, it's of 1 meter length. Right. So let us simplify this. What you will get? 2, it's 100, 8 by 100. So the answer is 0.08 volts per meter. So this is the potential gradient on the wire. Okay. So but in terms of millivolt per centimeter, how it can be written? X is equal to 0.08 into volt per 100 centimeter inverse. Isn't it? Because 1 meter is equal to 100 centimeters. So when you divide this 0.08 with 100, what you will get is 0.0008 volt per centimeter. In terms of millivolt per centimeter, how it can be written? 0.8 millivolt per centimeter. So that's how the potential gradient can be calculated. Okay, let us try one more problem. Let us try this problem. This is also a simple problem. It is from one of the previous medical entrance examination. What was given? A potentiometer wire of length 100,000 centimeters and resistance 15 ohms is in series with a resistance of 5 ohm and a cell of EMF 2 volts. The potential gradient along the wire is. So what was said in the question? A potentiometer wire of length 1000 centimeters and resistance 15 ohms is in series with a resistance of 5 ohms and a cell of EMF 2 volts. The potential gradient. So here also we have to find out the potential gradient. Okay, let us see. Let us try to find out what data is given here. Potentiometer wire length is given. L is given as 1000 centimeters, which is equal to 10 meters, and the resistance of the potentiometer wire is given as 15 ohms, which is capital R, and it is in series with a resistance of 5 ohms. So whatever this 5 ohms is there, it is referring to series resistance RS. Here whatever RS is present, so that RS value is how much? 5 ohms, and a cell of EMF 2 volts. So EMF of the cell is given as 2 volts. So the potential gradient along the wire is. So let us find out the potential gradient. Even here also internal resistance is equal to 0. So from this equation, X can be written as what? E. E is equal to 2 divided by R is 0, small r. RS is 5. 5 plus capital R 15 into capital R is how much? It's 15 divided by what? L is 10 meters. L is equal to 10 meters. 15, 10 meters. So what you will have here, you will have 2 0, 3 0, 2 gets cancelled. Okay, so you will have 3 by 20, isn't it? And 3 by 20, what? It can be written as volts per meter. These are the units. If you want, you can simplify this further. Okay, so this is how you are supposed to handle potential gradient problems. So whatever problems I have been, we have been discussing, all those things are confined within the limits of these details. Of course, there are many other applications of a potentiometer. We'll be discussing about those applications in the next sessions. But for time being, let us confine ourselves to these, questions, these kind of problems. Okay. Let us try one more problem. Now let us try this problem. What is this? The potential gradient along the length of a uniform wire is 10 volts per meter. B and C are the 2 points at 30 centimeter and 60 centimeter on a meter scale fitted along the wire. The potential difference between B and C will be. So here, I hope you remember the diagram of potentiometer. Okay, so there will be a cell and a wire will be connected in between points A and B, and this wire is called as potentiometer wire, isn't it? So here there will be a cell, there will be internal resistance, there will be series resistance, and you can have one key somewhere here. This is RS, this is small r, this is E. Okay, so what was said here? Whatever wire is there here, on that potential gradient value, X is given as 10 volts per meter. 10 volts per meter. B and C are 2 points at 30 centimeter and 60 centimeter. Let us say B is somewhere here at a distance of 30 centimeters. 30 centimeters B. And there is another point C, which is at a distance of 60 centimeters from point A. Let us say somewhere here. How much is the distance? 60 centimeters. Okay, and what this point is? C. Now, what is asking for? The potential difference between B and C. It's quite simple. It is something that is connected with the theory of potentiometer only. Just find out the separation between these 2 points. How much is the separation? 60 minus 30. So this is equal to 30 centimeters. So what he is asking for? He is asking for potential difference across a length of 30 centimeter. Across a length of 30 centimeter. Now, what is this potential gradient? This is potential per unit length. Potential per unit length. So this is how do we express this? We express this as X is expressed as V by L is equal to how much? 10. And V is equal to what? 10 into L. How much is the length that we need to consider in the given situation? 30 centimeters. So length of the portion of the wire between points B and C is 30 centimeters. So 10 into 30 centimeters, you need to convert that into meters. So you will have 10 power minus 2 because 10 is already expressed in terms of meters, right? So finally what you will have? 3 volts, isn't it? So potential difference between these 2 points or potential difference across this particular length of the wire is how much? 3 volts. Okay, so let us try one more problem. Now let us try this problem. An ideal battery of EMF 2 volts and ideal battery in the sense internal resistance is 0. Okay, an ideal battery of EMF 2 volts and a series resistance R. So here RS is given as R. Series resistance is given as R. Series resistance R are connected in the primary circuit of a potentiometer wire of length 1 meter. So what is the length of the potentiometer wire? It's 1 meter. So L is given as 1 meter. And the EMF of the ideal cell, ideal battery is given as 2 volts. Okay. And series resistance here it is mentioned as R. Okay. And this R is, so far in this data we have used R, capital R, to denote resistance of potentiometer wire. Okay. We have to be very careful. The length of the wire is potentiometer wire is 1 meter, and resistance of the potentiometer wire is how much? I'll write that simply resistance. Resistance of the potentiometer wire is 5 ohms. Okay. The value R, what this R is? Series resistance R, to give a potential difference of 5 millivolts across 10 centimeter of potentiometer wire. So indirectly, he is asking for a specific potential gradient. 5 millivolts of potential difference across 10 centimeter potentiometer wire. 10 centimeter length of potentiometer wire. So to get this situation, to have this much potential gradient, what should be the value of capital R? Here capital R is series resistance. Okay, so let us find out. Here potential gradient is given V by small l. V is how much? 5 millivolt divided by how much is the length? 10 centimeters. So in terms of what meters, how it can be written? 5 into 10 power minus 3 by 10 power minus 1 volt per meter, isn't it? So this is equal to, X is equal to how much? 5 into 10 power minus 2 volt per meter. So this much potential gradient we have to obtain. For that, how much this R value should be, capital R, or series resistance value, how much it should be, so that we'll be able to get potential gradient equal to 5 into 10 power minus 2 volt per meter. Let us see. We know that X is equal to what? This equation, E by R plus RS plus R into R by L. Remember students, here in this particular context, this R, capital R is what? In this formula, capital R is resistance of the potentiometer wire, and RS in the given data is equal to capital R. You have to be very careful, since this cell is ideal cell, internal resistance is 0, and the X value just now we have got, how much is that? 5 into 10 power minus 2, and E value, it is already given, 2 volts divided by RS. RS is equal to R plus potentiometer wire's resistance is how much? 5 ohms into potentiometer wire's resistance 5 ohms divided by length of the potentiometer wire 1. So if you calculate this, what you will get? 10 by R plus 5 is equal to what? 5 into 10 power minus 2. So let us cross multiply this. What you will have? 5R, 5 into R, 5R plus 5 5 is 25 is equal to, here 10 power minus 2, 1 by 10 square, it can be cross multiplied and you will have 1000. So 5R is equal to 975, R is equal to 195. So the series resistance should be 195 ohms. Okay. So this is how problems related to basic problems, all these are basic problems. We have discussed only these basic problems because we have so far completed theory of potentiometer only, and its applications are there. With the help of potentiometer, you can find out potential difference, as well as you can find out internal resistance of a cell. You can compare EMFs of two cells. Like that, several applications are there. In the next coming session, we will be dealing with applications of potentiometer. Okay, students. Thank you.